Hello everyone, I am Nagashri. Welcome to my civil engineering YouTube channel. Please subscribe to it and hit the bell icon to get notified when I post my new videos. Today, I'll be discussing regarding trusses, assumptions for analysis of trusses, method of analysis of trusses, numerical problems on method of joints, numerical problems on method of sections. So coming on to the first concept of this lecture series, that is trusses. So what is a truss? Truss is a structure which consists of only two members, only two force members. When combined, it behaves as a single object. So two separate members, it is combined so that it behaves as a single object. So the truss structure is only capable of resisting axial load itself. Axial load itself. Trusses are the members, trusses are the structure which consists of only two force members, and it behaves as a single object when it is combined, and it only capable of resisting the axial loads applied on the members. Basically, trusses are of two types. So first one is the plane trusses. It is two-dimensional in nature and member lies in a single plane, and space trusses are three-dimensional in nature and member lies in different plane. So this is a pictorial representation, that is a plane truss, which is two-dimensional and members will lie in the same plane, and three-dimensional truss, that is also called as a space truss, wherein the members lies on the different plane. So next, coming on to the assumptions for analysis of force in a truss. So there are some important assumptions in order to analyze what is the impact of the external load on the truss. So the first and foremost important assumption is that the external load acting on the truss structure will be acted on the joints itself. So whenever the load acting on the truss structure, the loads will only act on the joint itself but not on the members. So joints are nothing but they are the connections between the member to member. So member to member connection is given by the joints. So the next important assumption is that the self weight of the truss is neglected. So the self weight of the truss structure is always negligible. So the next important assumption is that the truss is generally connected by the frictionless pins. So it is nothing but the joints is always frictionless, or you can also state that always for the trusses the support will be always a hinged or pin support. So the support for a truss is always hinged or a pinned support. The last important assumption is that the cross section of the member is always a uniform. So I repeat it. So the external load will act on the truss only at the joint itself. The self weight of the body is negligible. The truss support for a truss will be hinged or the pinned support. Cross section of the member will be always uniform. Coming on to the method of analysis of the truss, generally there are two important methods for analyzing the truss. The first method is that the method of joints. Here, as in case of method of joint, it is a very simple method in order to analyze the truss member, and the principle behind this is that at every joint the algebraic sum of all the forces should be 0. So the next important method is the method of sections. It is one of the method in which the truss member is cut into individual members to analyze the unknown forces in a specific member, and it is a very fastest and easiest method to solve the unknown forces in the member of a truss. So I repeat it once again. So the method of joints, it is one of the simplest and easiest method in order to analyze a truss member. So in this method, we need to take up each and every joint in order to analyze the forces which is coming on to the each and every joint. We are supposed to put the equilibrium conditions for each truss, and then we the algebraic sum of and then we are supposed to state that we are supposed to assume that the algebraic sum of all the forces coming on to each joint should be equal to 0. And then in the method of sections we are supposed to take individual members. We are supposed to cut the truss into the individual members in order to analyze the unknown force for a specific member, and it is one of the fastest and easiest method to solve the unknown force for a truss. So I just take up a numerical example in order to analyze a truss by using the method of joints. So this is a truss given, so which is subjected to 80 kilonewton force at joint C. Here the supports are at A and D. So at A the support is a hinged support, and at D the support is a roller support. So here at A, B, C, D, E and F are the joints. So at joint C, it is subjected to 80 kilonewton load acting along right hand side direction, and at F the load is 50 kilonewton in the downward direction. So converting the supports into the reaction, step 1 is, so you have the two supports at A and D. So that is, one is hinged support and another is a roller support. So here we need to convert that supports into the support reactions. So as discussed in the earlier lecture series, the hinged support will have two reactions, two support reaction. One is in the horizontal direction, that is HA, and one is in the vertical direction, that is VA at joint A. So that is represented here. So again since at D it is a roller support, so for a roller support you will be having only one vertical reaction, so that is represented as VD. So here in step 1 I have converted the support into its reactions. Okay, so the next step is check for determinacy. So here we know that since it is a plain truss given, so in the previous lecture series I had stated that for a plain truss, m plus r minus 2j is the formula which is used to determine the determinacy, and checking for the determinacy is a very important step in order to determine in order to analyze the truss. Before analyzing the truss, it is a very important step so that we can check whether the truss is determinate or indeterminate. So the formula for checking for the determinacy of a plain truss is m plus r minus 2j. Here m is the number of members, r is the number of support reactions, and j is the joints given. So here, as in case of the truss given, we just count the number of members AB, BC, CD, EF, FD, and then EF, FD, AE, EC. So there are totally 9 joints, 9 members, and reactions R is nothing but the reaction forces. So at A there are two reaction, one is HA and VA. So at D it is only one reaction, that is VD. Therefore the total reaction for the overall truss member is 3, 2 plus 1, 2 at hinge and 1 at roller. Therefore R will be equal to 3 here. So J is the number of joints for the overall truss member. So number of joints is A, B, C, D, E and F. So there are 6 joints. Therefore M is equal to 9, R is equal to 3 and J is equal to 6. Therefore the structure is equal to, the determinacy will be equal to 0. Therefore the structure is said to be determinate. Means the formula is equal to 0. Therefore the structure is determinate. Therefore the structure is determinate. So the next, coming on to the next step, is that calculation for the support reaction, calculation of the support reaction. So we know that the number of unknown reactions are 3, unknown support reactions are 3. That is, at A is 2 reaction, that is HA and VA, and at D it is 1 vertical reaction, that is VD. We need to apply the equilibrium conditions. That is, first equilibrium condition is that sum of all the horizontal forces is equal to 0. For this equilibrium condition, I just take the sign convention as the right side going forces are taken as positive and left side going forces are taken as negative. So with this sign convention, HA plus AT is equal to, HA is going in right side direction. There are only 2 horizontal forces which is given here for the truss structure. So HA and AT, so both are in the right side direction. Therefore HA plus AT is equal to 0. Therefore H is equal to minus 80 kilonewton. So the next, applying the next equilibrium condition, that is sigma V is equal to 0. Sum of all the vertical forces is equal to 0. Therefore it is VA plus here before going to the analyzing the vertical equilibrium condition, I just state the sign convention. The upward going forces are taken as positive and downward direction forces are taken as negative. So there are 3 vertical forces. So 2 are in the upward direction, that is VA and VD. So one is in the downward direction, so that is 80 kilonewton in the downward direction, 50 kilonewton is in the downward direction. Therefore VA plus VD is equal to 50 kilonewton. So the next, that is equation 2, represented as equation 2. So the next last important equilibrium condition is that I just take the moment. Either you can just take the moment either at any of the support, either at A or at B. So either at A or at D. So I'm going to take the moment at support D. So here, as in before taking the before solving the equilibrium condition for the moment, I just state the sign convention here. Clockwise moments are taken as positive and anti-clockwise moments are taken as negative. So by applying the moment at point D, so starting from point A, VA into 3 is in clockwise direction, hence it is positive. So the next force is 50 into 1, it is in the anti-clockwise direction, hence it is negative, plus 80 into 0.75. Therefore solving this equation, VA is equal to minus 3.33 kilonewton. Substituting this VA in equation 2, so VD will be equal to 53.33 kilonewton. VA is minus 3.33 kilonewton. Minus represents, since it is a vertical reaction, so whether minus represent whether it is in upward or downward, as in case of vertical reaction. So minus represents whether it is in downward direction. So VD is 53.33 kilonewton in positive direction. So the next important step is that converting all the forces into its individual joint forces. So that is nothing but the free body diagram. So here I have represented the free body diagram by taking each and every joint into consideration. So here at joint A, so all the forces I have represented at all the joints. So and I have represented all the joint forces as tensile in nature. So you can just represent it as a tensile nature of forces collectively. So this is the pictorial representation of all the forces which are at each joint, so which is in tensile nature or tension in nature. So this is a representation. So as I said that VA, I have got it in negative direction, so I have changed it the direction. Here VA is in downward direction since it is a negative force, and VD is the positive direction, so it is in the upward direction. So coming on to the next concept, so that is, once again,